Thank you. Thank you. Yeah, my title of presentation. First of all, I am going to give my thanks and honor to the organizing committee to select me as a speaker. So my title of presentation is Using Indian Galena ore for preparing thermoelectric generator, pressure transducer and solar selective coating. That is, galena ore is basically a ore that India is the second largest mine in world. Yep. The first is Australia, second is India, where galena ore is available abundantly, and we can use this galena ore for preparing thermoelectric generator, pressure transducer, solar selective coating. So first of all, I am going to give the picture of how I am going to make the thermoelectric generator from galena. That galena ore, there are two types of galena ore are available. One is the chunk galena ore, which is in the form of chunk, that is a rock. Another is a beneficiated galena ore, which is formed in a powder form after the fourth flow technique. Then we have dope with the different dopant in different mole percent at inert atmosphere, like sodium sulfide, lead, indium, etc., to chunk galena as well as beneficiated galena ore. And we have make the pellet formation. This type of pellet we have made it, and then we have heated the pellet in inert atmosphere. We have sintered in inert atmosphere N and P type of pellet, and we have vacuum hot press of N and P type of pellet. Then achieve the optimum properties of thermoelectric properties, that is alpha means thermoelectric power, rho means resistivity, and K is the thermal conductivity. Optimizing the figure of merit, that is the Z is equal to alpha square by rho into K. Resistivity was found very low, that is micro ohm centimeter level. Thermoelectric power was 190 to 200 microvolt per degree Kelvin, and thermal conductivity was 6.6 into 10 to the power 3 calorie per centimeter per second centimeter Kelvin. That thermal conductivity are the two parts. One is the KL, lattice part of the thermal conductivity, and KEL is the electronic part of the thermal conductivity. Then coated this pellet with galena adhesive coating for prevention of oxidation and corrosion. Then made N and P type of couple by nickel contact. Contact was not very good, so the resistance has gone up and the output of the generator was very low. These are the generators. So we have made it. It is from galena ore to thermoelectric generator. We have filed 6 Indian patent which is sealed. Then I am coming to another part, that is the galena pressure transducer. Galena pressure transducer, the device that utilizes galena as its pressure sensitivity element. These transducers are used to detect and measure the pressure change, converting them into the measurable electrical signal. This is the pressure transducer we have made and we have commercialized also. The pressure transducer was made from the galena, chunk galena, as well as galena aggregate and galena concentrate, which is collected from the Johar mines, Rajasthan, India. The rectangular sample was prepared by cutting the natural galena, but its strength was very low, so it was not used for the pressure transducer. The sample prepared from the minus 124 into 10 to the power 3 to 104 into 10 to the power 3 nanometer means 120 to 150 BSS mesh size natural galena aggregate by cold pressing followed by sintering at 950 Kelvin for 12 hours in inert atmosphere, and similar is the vacuum hot pressing at 920 Kelvin at pressure of 13.97 into 10 to the power 6 nanometer. That is 0.9 tons per inch square for 20 minutes. So we have prepared the sample by sintering as well as by hot pressing. What I told, the galena cut from the galena aggregate were very low strength, so it was not used for the pressure transducer, but the pellet prepared from this size of mesh size natural galena particle, cold pressing followed by sintering showed a resistance decrease linearly with pressure up to 9.7 into 10 to the power 6 nano per meter square. Newton per meter square. Similarly, for the hot press sample prepared from the sample particle size, natural galena aggregate also shows that the resistance decrease with pressure up to 15.52 into 10 to the power 6 Newton per meter square after that reaches the saturation zone. Similar behavior was found for galena concentrate particles, that is cold pressing followed by sintering, and the vacuum hot pressing also. There also the hot press sample, the saturation point was at a higher pressure, that is 17.0 into 10 to the power 6 Newton per meter square pressure. The result and discussion. This is the result of variation of resistance with pressure of sintered plate made for chunk galena of this mesh size. This is the variation of resistance of the hot press plate made from galena particle. This is the variation of resistivity with pressure of sintered plate made from galena concentrate. This is the variation of resistivity with pressure of hot press pellet made from galena concentrate. Conclusion: from the above discussion, it can be concluded that the strain gauge could be fabricated from the natural galena aggregate or galena concentrate either by cold pressing followed by sintering or by vacuum hot pressing. Sample prepared from galena concentrate by sintering and by vacuum hot pressing has the highest change in resistance with pressure, suggesting that it may be useful for the strain sensor. We have 4 patents sealed, and this product is also commercialized. Then another part is galena-based solar selective coating. So we have made the solar selective coating by galena aggregate and galena concentrate. This characterization of the solar selective coating made from galena aggregate, galena concentrate collected from Johar mines, Rajasthan, where coating of galena are prepared by thermal evaporation technique, exhibit high absorptivity, that is alpha is equal to 0.95 to 0.97 in the solar spectral range, and the low emissivity epsilon 375 approximately 0.21 and 0.27 in the thermal range. Finally, these coatings were compared with the synthesized PBS coating prepared by our laboratory and found to be quite comparable. The saturation and the structure and the composition of the coating was studied by X-ray diffraction and the electron spectroscopic for the chemical analysis. Reflectance and absorbance study were also made in 0.3 to 0.31 micrometers spectral range. This is the coating, how we have made the coating of galena, chunk galena as well as beneficiated galena. We have measured the absorptions where we have used the alphatometer model A1 device and Services Limited USA. We have purchased this device. Where D and S of alphatometer is miniaturized pyrometer is specially designed for the measurement of the solar reflectance, absorptance, and transmittance. From this, we have measured, and thus the absorptance can be determined by subtracting from 1, since the fraction of energy is not reflected from the opaque surface body. This is the emissivity measurement. It is also measured with the help of D and S emissiometer model AE, which was also purchased from USA. We have done the X-ray as well as scanning of the surface, and this is the picture of the scanning, and we found that it is quite uniform, and our this surface gives a very quite absorbability, reflectivity, as well as the strength also. The result obtained this study indicates that the galena-based coating acts as a low cost, high temperature, solar absorbing surfaces may be good to the replacement of high temperature absorbing paint. In this addition, this property also coating possesses good resistance to the humidity, weather, temperature, and mechanical strength also. Further, it was also found that the optical properties were reproducible. It can be concluded by the proper control of the thickness of the layer. The grain size would be possible to prepare the low-cost solar lead sulfide-based selective coating for high temperature application, means around 400 degrees centigrade. This is the table of absorbability and emissivity of different particle size with different base plates: stainless steel, copper, brass, zinc, aluminum, galvanized steel. And thank you very much.